Assalamualaikum warahmatullahi wabarakatuh. Today I will present to you about experiment 3, free fall. So the objective of the experiment is to investigate the functional relationship between height of fall and falling time. The second one is to determine the acceleration due to gravity by studying the motion of freely falling body.
The apparatus that we're using in this experiment are falling sphere apparatus consisting of release unit, impact switch, digital counter, 4 decades, support base, right angle clamp, plate holder, meter scale, support rod, connecting cord and ball bearing. And the procedure are, the apparatus had been set up as in figure 3.1. A sphere that conducting an electricity was gripped in the release mechanism which closes the start circuit. Second, the pen adjusted using the adjusting screw under the arrest switch for a downward motion of a few tenths of a millimeter closes the stop circuit. The pen raised by hand after each single measurement initial position. Third, the radius of the sphere was standardized to a 3/4 inch, approximately 19 mm, which was determined the effectiveness of the height fall using the marking on the release mechanism. The aerodynamic drag of the sphere can be disregarded. So this is the result for experiment 3.
Experiment, we can get two types of graph. The first one is height of fall against falling time, and the second one is height of fall against the square of falling time. So we can see that the first graph, based on the result, we have got them increasing with falling time, and the second graph is we got the height is directly proportional to square of falling time. Next, question number 2. Using the height of fall as a function of the square of falling time graph, determine the gradient slope of the graph and calculate the value of G. And this is the calculation. Next, for question number 3, calculate value of uncertainties of G. And the answer is plus minus 1.19 meter per second square.
So for question number 4, what is the percent error in the experimental value? To calculate the percentage error, the G value minus the G standard over the G standard and times 100. Number 5, the experimental errors that occur in this experiment are the setting of the digital counter. The timer must be reset to 0 after the ball bearing is placed to avoid any zero error. Make sure the electricity that closes the circuit grip to 3 seconds before releasing it to avoid an error on meter scale.
Before ending this experiment, we were expecting to find that the higher height of fall will take a longer falling time taken for the ball bearing to land on the pen. Due to acceleration of gravitational forces, this experiment is called free fall, which is under one-dimensional motion topic. The result we get is as expected as our expectation are. At the height of fall is 0.05 meter, the time average we get is 0.0980 seconds, while at the height of fall is 0.50 meter, the highest height, the time average for the object to land on the pen is 0.3143 seconds, eventually proving our expectation to be right. As for the height of fall and squared falling time for each height, we get a consecutive data which is starting from 0.0096 second, 0.0178 second until 0.0988 second as stated in the conclusion. Based on this experiment, we have learned to hold on the switch coils tightly to make sure the electromagnet and electricity grip closes the circuit. This is for avoiding the error in meter scale. Next, we have learned to repeat the experiment continuously until we get an accurate and precise data.
Conclusion. The functional relationship between height of fall and falling time is linear. The higher height of fall is the longest time falling taken. At height of 0.05 meter, the squared time is 0.0096 seconds. At 0.10 meter, it is 0.0178 seconds. At 0.15 meter, the time is 0.0277 seconds. At the height of fall 0.20 meter, it is 0.0371 seconds. At 0.25 meter, it is 0.0460 seconds. At 0.30 meter, it is 0.0565 seconds. At 0.35 meter, the time taken is 0.0664 seconds. At 0.40 meter, it is 0.0788 seconds. At 0.5 meter, it is 0.0896 seconds. And lastly, at 0.50 meter, the falling time is 0.0988 seconds. So, the results we get in consecutive and linearly as shown in graphs. The acceleration due to gravity, g, by studying the motion of freely falling body that we get refers to graph A.
Next, we move to experiment 5, frictional force.
The objective of the experiment is to determine the coefficient of static friction of different surfaces.
This is free body diagram of a mass M lying on a horizontal surface where the normal force N is equal in magnitude to the gravitational force mg.
The apparatus that we use in experiment 5 are a wooden block, rubber cover at one side, 50 gram masses, 10 Newton spring scale, string and tabletop. Next, for the procedure, the mass of wooden block measured and recorded. The apparatus set up as shown in figure 5.2. The tabletop had been made sure it is stable and horizontal. The spring scale and wooden block attached with a spring, we place them horizontally on the tabletop. Then, a 50 gram mass placed on the wooden block. The spring will pull slowly and the scale's reading will be recorded. 7. Step 4 until 6 will be repeated for 3 trials. 8. Another 50 gram mass added on the wooden block, and step 5 to 6 repeated until total 500 gram mass on the wooden block. 9. Step 1 until 8 repeated with rubber side of the block facing upward.
And this is the result for rubber surface towards the floor and non-rubber surface towards the floor. The first analysis for the experiment is to draw and label the free body diagram of the wooden block. And this is the graph for static friction force against normal force for the rubber surface and non-rubber surface. And we continue to use the gradients obtained from the graph to calculate the coefficient of static friction for each surfaces.
For analysis 4, compare and discuss the coefficient of static friction obtained. So, coefficient of static friction for rubber surface is 1.13 and non-rubber surface is 0.20. And then we compare both of it and we get 0.93. So, rubber surface increased roughness of surface, creating greater coefficient of static friction than smooth surface. Okay, we move to the question part. Question 1. How can anti-lock brakes stop a car in a shorter distance than regular brakes? So the answer is, ABS pulls the brake in the manner to keep static friction in play rather than the weaker force of kinetic friction, thus stopping the car more quickly than it would with locked wheels. Okay. Next, question number 2. From your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? And what do you think determines the coefficient of static friction? So the answer is, rubber surfaces have the highest coefficient of static friction, which proves that the objective of this experiment. Different surfaces have different coefficient of static friction. For rubber surface, it is 1.13 and non-rubber surface is 0.20. The coefficient of static friction can be determined by ratio of the maximum static friction force between the surface in contact before movement commons to the normal forces.
Next, for question 3, once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. So the answer is, mass undergoes stop and go motion because the mass creates greater weight. With greater force downward, the mass cannot move smoothly because the friction that acts between the surface becomes greater.
Frictional force is friction occurs whenever two surfaces rub against each other. Friction is a force that always opposes motion. In this experiment, the frictional force between a wooden block and the rubber surface on a horizontal and inclined plane is measured, and from the plotted data, the coefficients of static friction are obtained. Static frictional force is depending on the type of the surface. Based on the results that we got after doing the experiment, when the rubber side of the block is faced downward, a wooden block with rubber surface is quite difficult to drag across a surface because it has high friction coefficient. But when the rubber side of the block facing upward, a wooden block without a rubber surface is easy to drag across a surface because it has low friction coefficient. From the experiment, we know that the larger the mass, the higher the static frictional forces. From this experiment, we have learned that condition of the surface is important because the inconsistency of the surface will affect the results. It will give us different force readings depends on the surface. If we repeat this experiment, there is no changes would be made, but some improvement to ensure this experiment done smoothly.
So lastly, for the conclusion, we can see that the factors of mass, surface and inclination, all of it are affecting the friction. The greater the mass is, the greater will the static and kinetic friction will be. Rougher surface yield a greater static and kinetic frictional force. When pulling an object up an incline, a steeper incline produces a greater static and it will cause a kinetic frictional force. In this experiment, we obtained that rubber surface increased roughness of surface, creating greater coefficient of static friction than smooth surface.